we can H plus ions are present in both acids and bases. So by measuring the strength of the concentration of this H plus ions, we can measure the pH of the solution. pH is not equal to the concentration of H plus ions. It is related to the concentration of H plus ions. Now let us see what actually pH is. pH is defined as the negative logarithm of the concentration of H plus ions. This box, square box, refers to concentration. And what is concentration? It can be some weight of the substance, like it can be number of moles, it can be in grams, it can be in kgs, it can be anything, divided by some volume. Like you have different types of concentrations. You can have gram per ml concentrations, like how much gram of the substance is present in 1 ml of the solution. You can have something like moles per liter. You can have, this is like how many moles of the substance is present in 1 liter of the solution. Like if you have H plus ions, how many moles of H plus ions are present in 1 liter of the solution. And this concentration is called molarity. Now we'll not be using concentration as such, but if we'll use molarity. Molarity is defined as the number of moles in 1 liter of the solution, number of moles of the substance in 1 liter of the solution, and it is denoted by the letter M. So this concentration is taken in molarity. How many molar H plus? We call it, if you have molarity 1, you call it a 1 molar H plus solution. And you might not be knowing, or you may have heard of this term log. Now let me explain that if you have Y is equal to 10 to the power x. Suppose we have y is equal to 10 to the power x. So we say that x is equal to log y. So this pH, which is, so x equal to log y means you remove this log and put a 10 to the power over here. So when you have to change from log to 10 to the power, you just remove this log and put a 10 to the power over here. And actually you should, since this is minus log, if y is equal to minus x, then 10 to the power minus x, then x is equal to minus log y, because minus x will be equal to log y. So x will be equal to minus log y. So log is nothing but the inverse of 10 to the power something. So basically this concentration of H plus is nothing but 10 to the power minus pH. So if you take log, you can take log on both sides. So okay, we'll not take log on both sides. We'll just put this 10 over here and it will go as log. This will become minus pH. And pH can also be represented as minus log. Since they are equivalent, you can also represent it as minus H3O plus. Now, there are some operations of log, like if you have log x to the power x square, log of x square. This power comes in the multiplication. So this becomes 2 log x. Okay. And there is a log table, like if you have y is equal to log 5 or log 6, you have a log table to find out the value of log 5. So you can find out the value of y from here. So suppose I give you H plus ion concentration is equal to 10 to the power minus 3 molar. It is 0.001 molar. So what is the pH of the solution? What you do, pH is equal to minus log of 10 to the power minus 3. Okay, put the H plus ion concentration in this. Now use that rule where the power, which is minus 3 in this case, comes in the multiplication. So this will be minus of minus 3 log 10, and this is 3 log 10, and log 10 is equal to 1, because if you have y is equal to log 10, we have 10 is equal to 10 to the power y. Just remove the log, put a 10 to the power. So 10 is equal to 10 to the power y, so y has to be 1. So log 10 will be 1. So log 10 is 1, so this pH will be 3 into 1, which is 3. Now this pH 3 means that the solution is acidic. You will find that for acid solutions you have pH between 0 to 7. For neutral like salts, you have pH is equal to 7, exact 7, and for basic we have pH greater than 7. So in this case our pH came out to be 3, so this was an acidic solution. So this 10 to the power minus 3 molar solution which we took was an acidic solution. And you see that the hydrogen ion concentration is 10 to the power minus 3 molar. So if it is 10 to the power minus 4 molar, so the pH will come out to be 4. And the pH will, and if it is 10 to the power minus 5, 10 to the power minus 6, it will come out to be 4, 5, 6. So this 10 to the power minus 4 is obviously less than 10 to the power minus 3. So as we decrease the concentration of H plus, the pH increases. So we are decreasing from 10 to the power minus 3 to 10 to the power minus 4 to 10 to the power minus 5, and the pH is increasing from 3 to 4 to 5. So as we decrease H plus concentration, pH will increase.